Hi guys, I am Dr.S.Nandhabalaji. Today we are discuss about the nanomaterials physical vapor deposition method like as a thermal evaporation method. In this evaporation method, thermal evaporation is a common method of physical vapor deposition method. It is one of the simplest form of physical vapor deposition and typically uses a resistivity heat source to evaporate a solid material at atomic level in vacuum environment to form a thin film. The material is heated in the high vacuum chamber until vapor pressure is produced. Physical coating process involve condensation and evaporation of material. PVD is used for high melting point and low vapor pressure material. It's an alternative process to electroplating. Physics vapor deposition's alternative sources are evaporation material, arc vapor deposition, ion plating method, sputtering method like as RF, DC and magnetron sputterings. In this assessment of PVD, what is the difference between physical vapor deposition and chemical vapor deposition? Why vacuum is created in chamber before thermal evaporation? What is meant by PVD coating? In physical vapor deposition, like as a three different types of work it's need. One is transportation and another one is condensation, final one is evaporation. First of all, evaporation work, condensed phase material, solid or liquid material is inputted the machine. It's evaporated like as a gas and transport to another gas phase, and condensation of solid phase materials. This is the schematic diagram of vacuum evaporation techniques. In this vacuum evaporation techniques, the sputtering target is fitted in the upper portion of the material. The thin film substrate is substrate into substrate place. The sputtering gas is it's beyond to the thin film. The high level vacuum is produced and the high level temperatures is used. The target is targeted and bombarded to the sputtering place, and the atoms are sputtered and it's coated into the thin film substrate. The evacuate chamber is filled with inert gas. The metal vapor migrates from the source into the color in inert gas, and the evaporated atom collide with the gas atom within the chamber and loses its kinetic energy. The metal vapor cools through collision with inert gas spices and become supersaturated homogeneously with particle sizes 1 to 100 nanometer, particle size controlled by the inert gas pressure, particle collected on a cooled finger by using liquid nitrogen. Scalped and exact size of nanomaterials are produced following factors of type of carrier gas used, pressure of the gas used, evaporation temperature, source to substrate distance. In the advantages of physical vapor deposition, environment friendly, then paint and electroplating. More than one PVD technique can be used for coating. Usually top coats are not required. Good strength and durability. Once it is generated, and another works are very easy. Disadvantages of cooling system are required. Mostly high temperature and high vacuum control needs skill and experience. PVD coating materials has no chemical interaction with the surface. These are the reference of this physical vapor deposition. Thank you guys. Thank you. We will meet the next class.